Okay. Next up, dear friends of mine, Mr. Christophe and Kimmo Koskinen. They're about to do some live coding in the cloud. Please welcome Christophe and Kimmo.
Thank you. So we are going to talk about Portkey. Portkey is a new library which we have been working on for, I don't know, 3-4 months?
Yeah.
I don't remember exactly. And Portkey is a magical artifact in Harry Potter's novels. It's a means of transportation. It's an object that when you touch it, you are transported somewhere else. However, we are going to give you some words of warning. It's not very comfortable. Some things may happen during transportation, so you may expect to lose something in the transportation. So you have been warned. But there are another warning.
Yeah, so if you are a tree, or if you have friends that are ants, horns, or groots, you'll be warned. Like there was a couple of weeks ago, this big storm where there were a lot of trees shaking. We will be also doing a lot of tree shaking. So you have been given a fair warning. So we have an idea.
Yeah, we really like the repl experience, and we wanted to try to bring the repl experience closer to the code. And so the idea is to really try to live code the code, to be able to define at the repl a function and expose it nearly immediately to in the code, and have it to be redefined and redeployed automatically as you type at the repl. So this was our goal.
Yeah, and we have a very, very detailed plan how we will achieve this.
Yeah, basically we had no idea where we were going, and somehow we were in uncharted waters. Actually, we found an old map of Scandinavia. It's from the 16th century, and we see that there will be dragons, a lot of dragons. And if you look elsewhere on the map, we can find the temporary area. And
it's really cozy. There are some woods on the south. There are some snakes. There's a lynx, I guess. But we don't have dragons there, so we are in a very safe place.
So one thing that really worked with us as a team is that we have really some aligned expectations. When I was very happy to have Hello World working, Kimmo was pouring cold water on me, saying that it doesn't work.
Yeah, I was trying it. I had a pet project, and whenever Christophe came, I was like, oh, okay.
And so I asked him why his lambda was not working. And guess what? I was just trying to get Hello World to work, and he was trying to get Hadoop to work.
So I have Hadoop in my lambda? Like, what could go wrong? So let's do a demo. OK. So I'm cheating a bit. I have a SSH connection to an EC2 server. And I have a project here with some dependencies. There's the closure core. There's the Portkey library. And then we have hiccup. So what I'll do, I will fire up a repl and start hacking away. So let's, as we are here, let's do, say, a welcome. So hello, closure tray. And see that I didn't make a typo. That works. So now let's pull in the machinery that is Portkey.
Sorry.
Okay, so that will pull in our borrowers, and we will be starting to track ourselves. So, so we want to lift this function somewhere away from our machine. Into the cloud. So we call pk mount, and this will do the lifting. We give the var, and then give a URL path. Seems that we have 4.5 megabytes. That will include closure core itself. So I click on the link. A couple of minutes. This will be live. The URL is a bit hard to type. So let's say maybe I do like this. So now, after doing this, you can start let's put like this here. Start trying out how well the Wi-Fi works.
No. You are putting the live true in the definition of the function.
So, sorry, I was getting ahead of myself. So now we'll mount and make it more live. Okay. So
the live true option means that further redefinition to welcome will be redeployed automatically.
So those of you who are quick, you can go and try visit this site. And I guess I will do so also. So we have a repl.portkey.cloud. Let's take the comma away. And here we live. So that's the initial hello world. This.
I think that we may have the smallest serverless deployment method.
Yeah, so you're at the REPL, and now you're in public internet. Just like that. So let's do something else. Let's pull some other libraries. There's this nice library called Hiccup. Let's take that, and let's do something else. Let's redefine welcome to use Hiccup. So I will do almost some HTML. So now there are many phones in the wireless, so that you will see lag while I was typing. Let's see. Oh, okay. Let's see. Body. H1. Then hello close tray. Close vector, and that one. Yeah. So now will be. There's a typo, but that kind of. This is a live demo thing, so there will be typos. So we can also. So that's another demo thing. So so there's live, but let's fix the content type. So that we have, say, text, HTML. We are kind of very conservative with the default that you give. This is through API gateway, so maybe you will be doing APIs more than web pages. Okay. Let's see if there's a demo effect. There probably is. Content type. Oh,
okay.
Yeah, cool. So, okay, one final thing. Like when I was doing PHP back in the day, you always had to have a kind of visitor count. So let's have a visitor count also here. So we'll define welcome there will be maybe something like this. Another piece of code. I guess this visitor count, I like it more than the PHP version. So let's put visitor count. And this will be swap of visitor count and increment. Did I get the curly braces right? Almost. Demo effect. So who can count? Defen welcome. There's 8 open.
You forgot to close the body.
Yep. I guess somewhere near here. Something like that. So
don't do that in production. The item is not going to be replicated.
Yep. But so what happens now is that we have oh, hey, there are many visitors.
Hey!
Cool!
Thank you, guys.
Thank you. You deserve an applaud.
Woohoo!
So, cool.
Okay.
Yeah.
So first, some words on how we managed to make this magical artifact. We scavenged overburrows from a project which we have both worked on, which is called Podokeg. Podokeg is a transducing context for Spark. So basically, it means that you can connect a REPL to a running Spark cluster and have it run any transducer, and that you can redefine stuff at a REPL. You don't have to perform any kind of AOT. And avoiding AOT is something that was needed to be able to deploy to the cloud. So we took our burrows out of Podokeg. Ouroboros is a snake or a dragon which eats its own tail. And the name comes from the fact that the JVM is connecting to itself as an agent to get full access to its classes.
Yep. So we'll be so now we get access to classes. We'll be packaging them. So current Amazon Web Services Lambda has a limitation of a hard limit 50 megabytes of the packets that you can run. There's a lower limit also if you upload on a zip that is only 10 megabytes. So we knew that we needed to do some tree shaking. And if you look at what options there are in pure JVM world, the go-to thing is ProGuard, but
yeah, the trouble that's ProGuard is GPL, and in our case we had to do some close integration with ProGuard, so it was a bit touchy on how to deal with that. And more importantly, ProGuard doesn't know a thing about Clojure. So we would have to teach or patch it a lot to deal with Clojure. And more importantly, since we were in some kind of experimental work, why not try to implement the tree shaker ourselves? So we built an experimental tree shaker on top of ASM alone at the start, and then on top of the ASM analysis framework. And the interesting thing is that since we are working from the REPL, we are not trying to remove dependency based only on static analysis of the bytecode. We have more information. We have the graph of objects that we want to share, so we can know more than ProGuard does, because we start from live objects. Okay. So how do our tree shakers work? We start from the function that we want to publish. Since it's a function, we need to serialize it. We serialize it using Cryo, because we can customize the serialization process with cryo, and something that we count with standard serialization.
Yeah.
And so while we serialize the closure, we keep a log of all the classes that we encounter during the serialization process. Serialization process.
Yeah.
And then, once we have serialized, we take these classes, we inspect their bytecode, we find other classes to add to the package, and so on. But we also keep track of the vars references that we find in the classes and the resources which are required by. Then, once we have closed over all the classes that we want to add, we look at the value of the vars that we have encountered, and we start over serializing them and getting new classes, and from classes getting new vars, and so on, until we reach a fixed point where we don't add anything else, and then we package it.
So
we do some sort of abstract interpretation to be able to understand some dynamic idioms that are found in code, whether in Clojure or in Java. If you want to.
Yeah, so we have, this has kind of limitations. If you, at runtime, the code decides to read a file and decide that I will load a class based on the contents of the file that is kind of outside of the scope. We don't kind of ever achieve that, but there's a way to manually tell keeps. So keep these resources, keep these classes. And so some libraries have a utility classes. Since we analyze only on the class level, not on the method level, big utility class that does a lot of references, we pull in more weight than we actually should be pulling. But it works. So I have a project of mine that I'm working in. We had a process that we got this export from a Hadoop cluster of a Spark job with packets of Parquet files. And so we want to put this into Redshift, a columnar store. If you put this library there to do the transformation, it weighs 90 megabytes by its own. You manually can prune it. I stop the pruning when I hit the 50 megabyte level, but you can compare with tree shaking. From original, we arrive at 40 megabytes. From manually pruned, we get 12 megabytes also off. And the lambda joy. You at the repl, you don't leave for deployment. You do deployment there. You have the deploy function that will create the lambda. You can give a name to it. We have the mount that will expose the function through API gateway. So API gateway can be configured with Swagger. So that is data. Clojure loves data. And we have been planning a spec support to kind of expose more than just get functions. We have URI templates for now. Are we done? Well, no.
No, there are still a lot of things that we'd like to do with this library. The first thing is to make the experience of the repl more fluent. So more reload, that is being able to reload a lambda even if one of the var that you depend on has been changed. And it also means reducing the latency, because since we are working from a repl hosted on EC2, there's not that much latency. But on typical case, it's the upload of the zip file which is going to create the latency.
Yeah, so that we could. There's an idea to solve it with readable that send only deltas. And another thing is this cold start that you observe. There's a couple of seconds. Every deploy is a kind of smaller cold start. But when the Lambda cluster restarts itself, there is always some kind of cold start that is due to. But there are ideas to kind of avoid that too.
So there are betterment to the tree shaking that we'd like to do, and especially be able to do the cross-class analysis that would allow us to get rid of many of the manual keeps that we have to put for some libraries. Then there's also the main point of being able to tree shake Clojure itself. Currently, we have blacklisted Clojure, and we don't try to tree shake Clojure itself, but I really believe that it would bring some improvement on the startup.
Yeah, and use spec for more for confirming inputs that we get from outside, like from API gateway or to the Lambda. And there's a lot of services in AWS that we could also kind of hook into with this. One of which idea of that is that we do a library that will be something like Amazonica, but will go and talk to this Amazon APIs directly. There's now a version that only does from specs kind of confirming. So this is kind of an example of a request that you would do to upload the function. And there's this create function request spec that could be used for that. So I guess, yeah.
So there are two things out of this project that should be spun off. First, the new bindings to AWS. We just spun them off. And the tree shaker is not very related to Lambda itself. And it would be useful as a general purpose for reducing the size of Clojure applications. So it should become a library on its own.
Yeah. So I guess that was it. The code lives in Portkey Cloud organization. If you aren't afraid of dragons or tree shaking, please come and try and hit us with GitHub issues or on Clojure and Slacks on Portkey channel. So you can find me on Twitter and Christophe also.
And so also on Slack and Sigwand everywhere for me.
Yeah.
And,
yeah. So thank you.
Thank you, too.
Hey, thank you, Christophe and Kimmo. Very good. So, any questions, the guys? There.
Hi. This looks fun. Are there any use cases which where you can use this project in my real project in production, or is it just for fun?
So for production, I think there are two sides. Either the kind of web service API gateway thing, but then like at work, I do a lot of data integration. So little lambdas that pull information somewhere, push them to Redshift, maybe do some transformation there. And they usually are quite small functions. And like the example that was there, I see that you could kind of lift Clojure alongside, say, Python and JavaScript that have kind of support even on the AWS kind of, there's a, on the web page you can type code, but you can't include dependencies. Here you can. So that kind of data integration side is where this would be maybe more immediately usable. After that comes the building web services, in my point of view.
Thanks.
To me, it's a tool to be able to spin off one-off ideas or project that I may have, that I quickly hack at the repl, and that I can just expose in no time. So for experimenting, for hobby stuff or simply getting something out very, very quick. Prototyping work, this is the kind of use case I have for it.
Okay, thanks. Time for one short, if you have a question, that is. Up there.
Hi, thanks for the inspiring talk. I mainly work in Python, and I've dabbled a bit in the web framework called Zappa, which is intended for serverless Lambda and API gateway stuff. Have you looked into that, and have you taken any inspiration from it? Zappa, among other things, makes it possible to run more than 50 megabyte packages in Lambda by loading them from S3 and live loading the code from there.
Yeah, so I haven't been, I don't know the Python framework, but there are similar ideas, like for the class loading, that when the Lambda runs, then we will be looking for dependencies. So that would kind of overcome also the limit. The thing is that if you have smaller amount of dependencies, you have smaller amount of code to load. So that makes for like a better startup time. But yeah, there are, I think, other endeavors in the same area that we just aren't aware of yet.
Yeah, in Zappa they noticed that the startup time is mainly dominated by the Lambda warm up, so when you download code from S3, that actually takes very little time, like 50 to 70 milliseconds.
True, yeah.
Okay, thank you, Kimmo and Christophe.
Yeah.